Perfect. So what we're going to do today, we are building on things that you did earlier this year. Um, and let me share my screen. There it is. Okay. So we're going to revisit moles. Let me get rid of my notes. We're going to revisit moles. And some of you may find moles difficult. Some of you might be new to year nine to this class. And I always like to revisit moles. It is the most important calculation within chemistry at any level. And then for those who finish it rather quickly, I want to have a look at empirical formulas, what they mean, how we use maths to solve it. And I'm going to make that one neater because that's just messy. Okay, so what's a mole? Okay, a mole is a way of comparing different elements and compounds. And to be honest, when you use it, so there's two things. There's an interesting definition of what a mole is. It's the amount of a substance compared to 1 gram of carbon 12 isotope and whatever. But that's not really the thing. It is really powerful because it's a very simple formula for working out moles. We revisited MR, so it should become quite simple. However, the problem is how you use formulas and which one you would use. And what I mean by which one, I mean which format. For example, there's the triangle. I don't like it. And there's nothing wrong with me not liking it. That's just the way I was taught. And when you're taught a certain way, you kind of adhere to that way of working and it kind of melds itself into your mind. The way that I like to do it is with a formula. Now, it doesn't matter which one you do. It really doesn't. Either way, you've got to remember them. Now, you've got two choices. Write your formula out every time you use it, gain lots of marks, and you'll become really good at it. The second way is don't write the formula out. You know the calculation, do it, and you will not really remember much of it. You will feel like you're fast, but it's really long term not the best for you. So either learn this triangle. If you know how to use triangles, use it, or learn the formula. And the formula is moles equals mass over mR. Now, there's another version. You can rearrange it. And I remember some students telling me this about 20 years ago. I was like, right, okay, if it works for you, mass equals Mr. Moles. Now, if you don't like rearranging formulas, just learn both of them. All right. And, well, what is moles? Moles is the mass of whatever you have in grams. In chemistry, it was always grams. And its relative molecular mass. Well, what's that? And I think the easiest way to revisit it is if I do number 1A. Now, when I look at number 1A, I've got 90 grams. I must work out the number of moles. So moles equals mass in grams. Oh, that's 90 grams. Lovely. It's already in grams, so I don't have to do anything. Divided by its MR. So what's its MR? This is H2O. All right. I'll lay it out because I don't know if all of you have done this before. MR equals, for H2O, what I'm going to do, the first step, is, well, what have I got? I've got H2, 2 hydrogens, and 1 oxygen. You then go to Newton's periodic table. Hydrogen's big number at the top. Yes, it's called atomic mass, but when I'm doing it, I'm not really thinking of the names. I'm thinking, you look instinctively. 1 plus 1 plus oxygen, which is over there, and it's 16. So your MR is 18. And all you do with your MR is pop it at the bottom of your formula at 18. So the number of moles of water in 90 grams is 90 divided by 18. So your number of moles is 5. Okay, and that's it. So for anyone who haven't taught before, who's new to year 9, please finish this worksheet. Everyone finish this worksheet, but some of you who I've taught for ages will be really fast at that. Now, empirical formula. This is really interesting. There's a molecule called benzene. That's its formula, C6H6. That's its molecular formula. However, its empirical formula are the numbers in its simplest form. And what I mean by that is, these 6 and 6 are both in your 6 times table. You can divide them both by 6, and it'll give you C1H1. We're exactly like maths, we don't write 1. So the empirical formula is CH. You simplify it down. Okie dokie. Now, when we look at something rather more interesting, I'm going to look at the calculation. I'm not really interested in these. That's maths. I'm really interested in this. So what do I do with this? There's a rule in chemistry. If you're doing a calculation, you've got to do something in moles, all right? Especially for, Key Stage 3 and GCSE. This is not moles, it's percentage. And in my head, instead of having moles equals mass over MR, well, I can think of the percentages as mass. So I could think like 82.4 grams of nitrogen to 17.6 grams of hydrogen. So I'm going to write this out. N and H. Let's just put that there. Don't need to, but I just did. 82.4 and 17.6. Looking at the formula, I've got to divide everything by its MR. Well, nitrogen, look on the periodic table, is 14, and hydrogen is 1. Anything divided by 1 doesn't change, so that's 17.6. Now, 82.4 divided by 14, even me, I'm not going to do it in my head, all right? Even if the numbers are really easy, like 25 divided by 5, I still put in a calculator. The reason being, we make stupid mistakes. I've done some beauties. All right? Now, 82 divided by 5.88. I've rounded up. Okay? So when you get to this point here, the trick about ratios is divide all of them by the smallest number, which is 5.88. Anything divided by itself, 5.88 divided by 5.88 is 1. And 17.6 divided by 5.88, I think it's about 1.5, no, 2.99. 2.99. All right, so we want a whole number. That's really close to 3, so we just round it up to 1 to 3. Now, if you look at the top, nitrogen is 1, hydrogen is 3. So we write N. We don't put 1 there because we don't bother. And hydrogen, whoopsie daisy, is 3. So that's the formula, the empirical formula. All right. So I've recorded this. It's 8 minutes. If you get stuck, look back at what we've done. All right. Take your time and enjoy. Okay, I'm just going to finish with this. Write out your formulas. Right.